Hi there. So in a previous video I said that I would like to use a modern USB mouse with a old Mac 512K from the mid-80s. And the reason is, well, frankly, I want a challenge, and also I don't feel like spending money. So this video will kind of explain how I go about this. I haven't actually built it yet, so this will be, you know, a real-life development video. Alright, so this project is pretty clearly divided into two parts. First part being, how do you tell the Mac where the mouse is going? And the second part is, how do we read what the mouse is actually doing? So let's tackle the first part. Alright, when your research takes you to tripod, you know you've got something good. But anyways, here I've got the pinout for the mouse connector in the back of this thing. There it is back there. And it's a very simple device here. You've got just your 5 volts, ground, you got one pin dedicated to the mouse button, and then you've got two quadrature-encoded inputs, one for vertical, one for horizontal. Well, what is quadrature encoding? Well, it's basically what you'd get out of one of these rotary encoders. So here's a little table, and this is what the pulses look like over time. So basically with this type of encoding, with just two lines, you can tell the direction of the rotation as well as the speed. The former by seeing which line changes before the other, and the speed just by counting how fast the pulses change, or the lines change. So this is really easy for, say, a microcontroller to generate. Well, now that we know how to talk to the Mac, we can worry about this thing. Now, old mice, you know, the ones with balls, actually did use quadrature encoding, at least internally. But modern mice, you know, the optical mice, do not use anything like that. So we've got to figure out a way of getting mice like this to tell us, you know, where they're moving over USB. Now, you might be thinking, well, USB is kind of difficult to use because it's a complicated protocol. You've got to implement all the HID routines, you know, human interface device routines, and all that kind of stuff. Well, fortunately, mice have a little quirk. USB mice, and also USB keyboards, if they don't detect that they're being used with a real USB, they will typically fall back to PS2. You know, the circular plug? Now, it turns out that PS2 is really easy to interface with the microcontroller. It's basically, you know, 5 volts, 0 volts for power, and a clock line and a data line, and they all work at 5 volts. So this is really trivial to interface with, say, an Arduino. And there's actually libraries that other people have written that do that task very well. So I think it's about time that we summon the master of all things Blinky, the Arduino. Yes, he will help us prototype this. Alright, let's open up the box of connectors, and hey, in a not at all choreographed location, we have my only D9 male. I would have much preferred one with like a, you know, a solder cup version with a housing around it so that I could build in my electronics there, but for prototyping work this will do nicely. Takes care of that. Now I just need to search for a USB connector. Well, this thing will have to do. It's an old, what is this? TiVo. It's an old TiVo. These guys are jerks. It says here, confidential and proprietary. Yeah, okay. How's this for confidential? Look at all these chips. Look at the back, too. Jerks. But anyways, at least I'll be able to use their USB connector. I didn't want really to use this one because there's two, but again, this is just a prototype. I'll go get some real parts later. Alright, frankly, the part that scares me the most about this project is actually the interface between the Arduino and the Mac. Not because it's a particularly difficult protocol, it's just I'm not sure of the condition of this mouse port. So I'm going to start with that, because I can definitely get more mice easily, but I can't get one of these too easily. So I'm going to wire this up, program the Arduino to give the Mac, a constant, down and to the right movement, say, or maybe some random movement, things like that, just so I can make sure that I can actually talk to this thing. And then if that proceeds as planned, then we can start hacking on the mouse. Now if you look at the pinout of this mouse, you can kind of tell why people started moving away from these basically raw mouse protocols to serial protocols such as PS2, because you've got so many lines you've got to hook up. You've got the 4 movement lines, plus a mouse button, plus 5 volts, plus ground. That's a total of 7. So, I'm going to have to use some of this spare Ethernet cable. Well, it's not Ethernet. Ethernet type cable. And, solder this on, and let's crack on with it. Alright, so it's important that I check my assumptions here because I don't want to explode this thing. So I've got the cable hooked up, I've got my meter hooked up to the probably 5 volt line, but we'll see. So as soon as I hit the switch, we should get 5 volts. Alright, cool, we do. Or close enough at least. So that should be able to power our contraption and get everything running. Cool. Now time to do a little bit more wiring and we can proceed. Alright, so I'm actually going to reuse this little section of lights that I had previously for a different project, because it will be the perfect debug array here. So each light will be corresponding to one of the channels of the quadrature. And I've wired this up so that I've got the power down here, I've got the mouse button up here, and everything else, the quadrature in the middle. So I can just plug this sucker in, hook up some ground, if I can. Got some ground. Now I just need, let's see, we're going to scavenge. There we go. This will do nicely. Got +5. So another sanity check. As soon as I turn this on, this thing should light up. And it does. Cool. Alright, so I've written a quick little program to simulate a mouse moving. So the bottom 2 are the horizontal and the top 2 are the vertical, I think. And if you look at it, it's very easy to see how this quadrature encoding works. I have it doing basically 8 steps in one direction and then 8 steps in the other direction. And you can tell, there it goes, it just reversed direction. Now it's going to reverse again. So it's very easy to see how this encoding works. There we go, backwards, forwards. And the code itself is very easy. I took the simplest approach. I have this array of all the encodings in order. I have, keeping track of where I am for each channel for horizontal and vertical. Some bookkeeping. And that's all. I have my loop. I push my quadrature outputs, which we'll look at in a second. If we're going forward, then I increment the horizontal step and the vertical step. If not, then I decrement them. And if I've gone enough steps in the current direction, then I reverse. And then I wait a little bit. And writing the quadrature outputs is very easy as well. I grab the value, the appropriate one of these. I do a little bit of bit math. So I take the right hand bit and push it out to the first, to the A of the horizontal, so the first line of the horizontal. Then I take the one bit to the left of that, so I shift this to the right, and I grab the rightmost bit, put that out to port B, and I do the same for the verticals. And this modulus in here is just to make sure that I don't have to worry about limiting my index here, so I can just keep adding. I can just keep adding 1 to this, and this will just all work out down below here because I'm taking the modulus. Yeah, sorry, that was probably quite confusing. Basically, what this modulus does is it cuts off and uses only the rightmost the rightmost 2 bits. So basically, I can increment horizontal quad step, like I do up here, as much as I want, and not care that I go over, 3, which is my maximum index here. I can just keep adding and adding, or subtracting and subtracting, but the last 2 bits will always be correct for the purposes of indexing into this array. So hope that made a bit more sense. Alright, so I've increased the speed of this animation here, and I've also increased the number of steps. It's got a nice mesmerizing quality about it. Very blinking lights. But anyways, I'm going to hook this up to the Mac and see what the heck happens. I hope it works. So yeah, moment of truth. I've plugged this into the Mac. Now I'm going to flip the switch, and hopefully we'll see this cursor scampering across the screen and not a bunch of smoke. Come on, screen, warm up. Well, the mouse cursor isn't where... Oh, come on, wake up. Yes, the mouse cursor is moving. There it is. Success. Ha ha ha. See, it's moving up and down in a diagonal line. Alright, now it's time to hook up the mouse. The real mouse. Alright, well, like I kind of alluded to earlier, wiring up the USB mouse is just a matter of wiring up the mouse as a PS2 mouse, except through a USB connector, because those little adapters that you can get that connect your USB mouse to PS2 connector on your computer, they're just wires. There's no active circuitry at all in there, or passive for that matter. It's just straight through wires. So you can see here that the data minus line in USB becomes the data line on PS2, and the data plus becomes the clock. So all I need to do is wire up my USB plug and pretend it's PS2, and then basically use the pre-existing Arduino library for PS2 and use the mouse as normal. Should work just fine. Alright, well, as it turns out, this mouse doesn't have the backwards compatibility with PS2, so I can't use it. But that's okay. I've rigged up through this USB cord. I have the little test program provided with a PS2 mouse library, and as I move the mouse, as you can see, I get values. And if I click, I get different values as well. So that's working pretty well. So now I just have to put 2 and 2 together. Alright, so I've hacked up the firmware to use the mouse, and as you can see, as I move this around, I get blinking lights, and if I click the button, either button, I get the button light, which I've added. So now, moment of truth, let's hook this up to the Mac and see if we can move around. It's possible that I've screwed up the up and down and left and right, so it might be mirrored in some axis, but that's easy enough to fix. Alright, let's see what the hell happens. I added some protection resistors between the Mac and the Arduino just because I'm paranoid. So hopefully it'll still have enough drive current to make everything work. Power on. The mouse, okay, the mouse is working. Come on, I see the light. It's not great. Wow, it's actually quite terrible. Well, there's some bugs. It works in the general direction that you want to go. Well, except the axes are reversed, but wow, that's actually pretty terrible. Alright, well, I need to work at it, I suppose. Well, as is often the case with these things, the Arduino was actually outrunning the Mac. I was outputting the quadrature encoding way too fast, and so now it works. Let me zoom in a little bit. Manual zoom, of course. But yes, there's the mouse cursor, moving up, down, left, right. So, success. It still goes a little bit crazy if I move too fast. It does this weird rectangle thing, but I think I know why. I just need to tweak the software a little bit. Alright, so I adjusted the delays a little bit, and now it is absolutely perfect. It tracks my every move. No problems whatsoever. Awesome. So that only took a couple hours. It is 1:30 a.m. I started around 10:30, so not bad at all. Alright, I suppose I should explain how the software works, even though it's pretty simple. Of course, I'll post all this up once I actually have some finalized circuitry and that I can actually present. I'll probably post that on my blog. But anyways, I've added some mouse initialization code. Of course, I'm using the PS2 library for the Arduino. Anyways, I give it the proper pins, I initialize it. This is all taken directly from the demo of the mouse library. So I still initialize all my stuff. Now, however, I actually query the mouse for the amount of distance that it's moved in the X direction and the amount of distance it's moved in the Y direction, and the state of the buttons and all that. Again, this is all copied pretty much straight from the demo code. Then I set up these two booleans so I know if I'm going right or not, or down or not. And then I take the absolute value of everything just to make my loops easier. And then for each horizontal step, I increment the quadrature encoding. I write it out, and I wait a little while. I had to add this, as you saw, because without this delay, the cursor wasn't really following because we were outrunning the Mac. Doing this lets the Mac register the new quadrature value, and then we subtract 1 from the distance, and then we do this once for every pixel moved. And then we do the exact same thing with the Y, and then we write out the the button state, or rather the opposite of the button state, because apparently the Mac has an active low button. And then I also write the LED pin on the Arduino, just so I know that the thing is working. And the horizontal and vertical quadrature outputs have been split out into their own function just to make these loops a bit more efficient, but they are exactly the same as before. So that's how the software works. But anyways, this should all be released under GPL, so it doesn't have the copyright notice, but that's what it's under, because I say so. GPL v3 to be exact. So let's plug in the OS and let's make a copy of the OS, so I don't have just one copy. Oh, come on. Wait. Yeah, system disk. Don't tell me it's dead now. Uh-oh. Oh, now it's being a jerk. What the heck? We want to bet that the mouse button is stuck on. Yeah. Yeah, the mouse button, I'm doing the opposite. So, oops. That's okay. It's clearly working. Let me just reverse that into firmware on the fly, because I can do that. Plug that in, and I'm writing I can reach back there. On the flip side, I actually now know that pushing down the mouse button on startup for a Mac will actually cause this to eject. How convenient. I didn't know that before. Anyways, here we go. Let's load up Mac Write. Disk is too full. Okay. Well, I'll just have to use this 800K drive, which I thought it was a 400, but it's an 800. And, yeah. We can go to town. Oh, and by the way, I was right, there was a RAM upgrade. I mean, but massive amounts of sims kind of gave it away. But yes, it is 2 meg. So this is a Mac 512K, except it's 2048K. Imagine that. That's cool, actually. That means I can run a whole bunch more stuff. And then the next step, I'm gonna stop by my local electronics place, pick up a bunch of real parts, and then probably port this over to a much smaller ATTiny or something like that, because this chip is way more powerful than it needs to be. And ideally, I just like to make a port or a little adapter thing that plugs back here, that has a USB plug on one end and the D9 on the other, so that you can just plug in a mouse and not have to worry about extra cables or anything like that. But anyways, hope this was interesting. I will post an update when I have some prettier hardware.